Hello, and welcome to our Spring Boot series. Today, we're diving into the heart of Spring's magic, component scanning. Let's unravel how Spring Boot makes your development faster and more efficient with this powerful feature. So, buckle up and let's get started. What is component scanning? Component scanning is a mechanism where Spring automatically discovers beans and registers them in the application context based on annotations found in class files. Common annotations that mark a class for component scanning include @component, @service, @repository, and @controller. These are stereotypes for different layers of an application. Component scanning is enabled by default in Spring Boot applications. You can further customize it using the @component scan annotation if necessary. When you kick off a Spring Boot application, this radar gets activated, scanning your project for these annotations and registering them in the application context. This process significantly cuts down the manual work of bean configuration. This automation significantly reduces manual configuration and helps in managing large-scale applications more efficiently. How it works? Let's dive deeper into the heart of component scanning in Spring Boot and see how it really works. Imagine your Spring Boot application as a bustling city, where each component is a building with a specific purpose. Let's look at our Spring Boot project. That's our main Spring Boot application class. That was created by the Spring Initializer. It all starts with your main application class, annotated with its Spring Boot application. This is like the main gate of our city. The Spring Boot application annotation is composed of three annotations: Spring Boot configuration, enable auto configuration, and component scan. Spring Boot configuration annotation. It is internally composed of configuration. So Spring Boot application also contain configuration annotation. Configuration annotation is able to register custom beans with the @bean annotation or import other configuration classes. Enable auto configuration annotation. It enables automatic configuration of your application based on the libraries present on the class path. This annotation attempts to guess and configure beans that you are likely to need. Essentially, it enables the auto-configuration feature of Spring Boot, making it much easier to set up your application. Component scan. It enables component scanning of the current package and also recursively scans the sub-packages. This tells Spring where to start looking for components. The Spring application.run method is a static method which takes the actual name of our class and args as input. It serves as the entry point for starting a Spring Boot application. It bootstraps the application, starting the Spring application context, and performs the class path scan, register all bean in application context, auto configuration, and configuration loading and start application server of us. This method is typically called from the main method of your application's main class. Let's now return to the topic of component scan. By default, Spring scans all packages under your main application class's package. In our project, it scans only com.gan.darpun.springboot or all its sub-packages by default. When the application starts, Spring scans the packages for classes annotated with component-related stereotypes. Once a candidate component is found, it creates a bean definition and registers it with the Spring application context. The bean is then available for dependency injection and can be auto-wired into other classes. A common pitfall when using Spring Boot is deciding to use packages outside of the default package. Suppose I want to use. Here's an example. So we have our com.gan.darpun.springboot, which is the package of our main Spring Boot application class. But you may want to create other packages outside of the main class, called com.componentscandemo. But Spring Boot will not scan these packages for components. It will only scan the package of the main Spring Boot application class and its sub-packages. So, the default scanning works fine if everything is under com.gan.darpun.springboot. But what about my other packages com.componentscandemo? How will this kind of setup work out, or how can I configure this accordingly? Spring provides a way to customize the base packages for component scanning. In the Spring Boot application annotation, you can specify that the base packages using its scanBase package classes attribute. Alternatively, you can also use the @componentScan annotation explicitly along with Spring Boot application and specify the base packages using its base packages or base package classes attribute. Let's do hands-on. Let's get started. Open your Spring Boot project in IntelliJ. In the last constructor injection video, we already saw that Spring will scan all subpackages. So I will not show this again. Let's move directly to the next part. If all classes are parallel to our main class, what will happen? Select all classes present inside the constructor injection demo package. And move all selected classes to the com.gan.darpon.springboot package. Next, restart your Spring Boot application. OK, our Spring Boot application gets started. Open web browser. Open the greeting REST API in the browser. We have already created it. It's working properly. It returned expected response. Now, let's have some fun. What happens if our controller code is in the constructor injection demo package, and the other service code is parallel to the main class file? Next, move the controller code to the constructor injection demo package. Let's restart our Spring Boot application. OK, our Spring Boot application has started. Now, open a web browser. Open the greeting REST API in the browser. Wow, it's also working as expected. Next, let's move on to the topic, what happens if our class is outside the com.gan.darpon.springboot package? Next, move Notification Service and Notification Service Impl to the constructor injection demo package. Create a new package called com.componentScanningDemo. Next, move Greeting Service and Greeting Service Impl to our new package, com.componentScanningDemo. And again restart Spring Boot application. Oops, something went wrong. Our Spring Boot server failed to start. As we can see in the logs, parameter 0 of the constructor in com.gan.darpon.springboot.constructorinjectionDemo.constructorinjectionController requires a bean of type com.componentScanningDemo.greetingService that could not be found. What happened here is that Spring Boot scans our default package, but it doesn't scan our greeting service classes located outside of the default package. Consequently, Spring doesn't create a bean for the greeting service class. However, the constructor injection controller class is present inside the default package. So Spring identifies the need to create a bean for it. Spring attempts to create a bean for constructor injection controller. But during this process, it discovers that the controller requires a dependency of type greeting service. Spring then searches for greeting service in its application context or container, but doesn't find any such class. As a result, Spring throws an exception. How to do it? Don't worry, we've already discussed how Spring provides custom configuration for package scanning. Open main class file. In the Spring Boot application annotation, add scanbase packages and set its value as an array of packages that need to be scanned. For me, scanbase packages equals com.component scanning demo and com.gan.darpon.springboot. Now start our Spring Boot application. This time our application has started successfully. This time, we instructed Spring, "Hey Spring, kindly scan com.component scanning demo and com.gan.darpon.springboot." Spring scanned both packages and their sub-packages for me, creating all beans present in both packages. It is useful when you add any other third-party library to your project and want all packages to be part of the Spring container. This configuration is very helpful for configuring custom package scanning and registering beans in the application context. Now, open a web browser for testing. Open the Greeting REST API again. Previously, we passed the base package parameter inside the Spring Boot application annotation. Spring also provides the component scan annotation for this purpose. Let's try using that. Add component scan annotation and add scanbase packages equals com.component scanning demo and com.gan.darpon.springboot. Restart Spring Boot application server. Some best practices you can follow when configuring package scanning in a Spring Boot application. Logical structure. Keep your application's package structure logical and intuitive. This helps in effectively utilizing the default scanning behavior. Avoid default package. Do not place your classes in the default root package. This can cause Spring to scan too many classes, slowing down startup. Selective scanning. Use filters to exclude unnecessary components from being scanned. This can improve startup time and reduce memory consumption. Common pitfalls. Component not found. If Spring can't find a bean, ensure it's correctly annotated and located within a scanned package. Circular dependencies. Be mindful of circular dependencies between beans, as it can cause the application to fail at startup. Configuration overlap. Avoid overlapping configurations that might cause some beans to be scanned and registered multiple times. Thank you for watching. Be sure to subscribe to our channel and hit the notification bell to stay updated on the latest tutorials.